So, hi everyone to this talk about continuous profiling, the fourth pillar of observability. So, my name is Marcus Hirt. I'm the Director of Engineering for the Continuous Profiler at Datadog. I'm also the JDK Mission Control Project Lead for OpenJDK. I'm also part of the Java Vulnerability team, and I'm a Java champion. If you go to Google or somewhere and ask, what is profiling? You're probably going to see something like this. The recording and analysis of a person's psychological and behavior characteristics so as to assess or predict their capabilities in a certain sphere or to assist in identifying categories of people. That sounds a little bit Big Brother, but it's obviously, the FBI kind of profiler that you've seen in TV series and movies. So if we translate this to software profiling, it's still about behavior. It's about understanding the behavior of your code, your program's runtime behavior. And for continuous profiling, it's in production. And you do this for a bunch of different good reasons. You do it maybe to improve performance. That's common. You might do it because you want to reduce cost. That doesn't necessarily need to be the same thing, because you can sometimes pay more to get things to go faster. You might want to do it because you want to improve the understanding of the code that you're running in production. And that can actually help with improving the decisions around that code. If you know how your code is executing on a Black Friday, you might do better in the future when you're making decisions around that code. You can also do it because you want to improve team velocity. Personally, I think that one is more important than any of the other ones. I'll talk a little bit about that later. So today there are three pillars of observability that are widely recognized. You have metrics, logs, and traces. This is a talk about the profiling part, I might as well just quickly tell you about these. So a metric is a measurement captured at runtime. You have a time associated with that metric. It has some associated metadata so that you can filter or aggregate that data in different ways. And the powerful products that you will find out there has some really good features around dashboarding. You can put dashboards out. You can detect automatically changes and variance in those values. They usually have powerful query engines so that you can put together composite expressions, algebraic expressions for your, these values, these metrics. And they typically have alerting capabilities, so when something goes out of whack, you can get alerted. Also predictive capabilities is actually pretty cool. Then you have logs. So logs are time-stamped records with optional metadata. It's what you would typically, use SLF4J or, Apache logger behind SLF4J or something to do, right? You system out log or something. Well, actually logger log in this case, but these logs are captured, and the really powerful projects out there have really sophisticated analysis capabilities, analyzing those log lines, looking for patterns. For example, if you have log lines that have numerical expressions in them, you would be able to see the range of all those log messages that you've done, and you will see histograms over the distribution and stuff like that. So very, very useful to have a product like that. And then you have correlation with other products like tracing. So that's the second pillar. The third pillar is tracing. So tracing provides the big picture of how your application is running in your production system. The tracing capability, a trace is really the path the request takes across your entire application. It consists of spans. So trace is really a directed acyclic graph of spans. And a span is just a unit of operation, something that you find that is usually interesting to know about. You have an ID for that trace, you have an ID for the span, have a parent ID because you want to be able to drive the graph, start and end times, attributes, and context is propagated between processes over the network. So you can truly see how some request has gone through your entire application. So that's tracing. Now, there was an open, it's making a lot of noises up here when I move around. I'll just stand still. So there was an initiative to standardize these tracers so that they could interoperate in a good way. So that was open tracing. Now, of course, there is more signals than the tracing signals, so eventually open tracing became part of the open telemetry initiative, and that's really the initiative right now for these kind of capabilities. And since since May 2022, there is an open telemetry profiling signal group that is working on standardizing continuous profiling. So there's ongoing work to define a standard format. There is a lot of companies involved in this. So Datadog is one of them. That's where I'm from. Red Hat, Google, Elastic, Grafana, Polar Signal, Splunk. You know, most of the names are there working this problem. And the idea is then to have continuous profiling be another signal. Back in the day, profiling was something that you did once in a while. Typically when you had a serious performance problem and you really needed to do something about it, a customer, somebody decided that this is not good. It was sometimes practically done close to release or something, but you know, you didn't do it that often, and you typically did it to gain very detailed information. You would marvel at all the information you could get. You could cycles per instructions, clock cycles retired, pipeline stalls. There is no end to the information that you could get from these profilers. And you didn't care too much about the overhead back then, because, well, you mostly ran the profilers locally by the developer at development time, and you mostly just cared about CPU. That was your #1 resource that you cared about. And applications back then were decidedly less concurrent, well, less parallel at least. You didn't have that many hardware threads. And the runtime integrations back then were so-so. You would see a lot of mixed samples, unwalkable stacks, stale or missing metadata. Today things are way more complicated because there is not just one process running. We're talking about massively distributed operations. Tracing is now commonplace. There is a context. You can see how things are actually executing in runtime, at least where the big blocks are. You typically don't do one release of shrink-wrapped software every once in a while. You actually release multiple times a day these days. And there is not a single development team. You might have plenty of them. And they might not be shipping one artifact. There might be quite a lot of them. And as we have learned at Datadog, it's not just CPU affecting performance. Actually, these days, it's rarely the bottleneck. So it's not just CPU profiling that is interesting anymore. So I thought I'd take a short trip down memory lane to explain how I kind of came into continuous profiling, because it is also going to explain some of the reasons why this ended up being a thing. So a very long time ago, I think it was 96, might have been 95 actually, a bunch of friends from the Royal Institute of Technology here in Stockholm created a company. The company was called Appeal Consulting and Data Consulting and Multimedia. And the multimedia part of the name was actually so that I and another guy could deduct the value-added tax from synthesizers. So that's how all of this started. And then when people started to get done with their degrees, there was a question about what we would do next. We had saved some money from our consultancy work to build a company together, and we decided that we wanted to build a high-performance JVM. And yeah, another funny story, we wanted to license the class libraries from Sun Microsystems, because we wanted to build a very fast server kind of runtime. We didn't want to deal with building, you know, the AWT library or things like that. So we wanted to license the class libraries. We're looking at Harmony and other green room implementations, but we decided to eventually license it also for the test suites to prove compatibility with Sun Microsystems Hotspot JVM. And we also wanted to call it Java Virtual Machine, which you couldn't unless you licensed. Otherwise, you had to call it a virtual machine for Java. And funnily enough, that matters. Anyways, in that application, we had to specify a value add. So it wasn't just that, you asked to be licensing and pay some money, you also had to specify some value add. And we said superior performance is the value add. To which Sun Microsystems didn't respond well. They said that that is not a value add. So we had to come up with something else. And that's how the JVM management console was born. So we said, yeah, but we have a JVM management console. Is that a value add? And it's like, yeah, that's a value add. So that's kind of how the observability stories around JVMs started. After that came JRockit Runtime Analyser in 2001. The company built a low latency GC called Determined GC, and that was kind of the origin for JFR, because we needed to understand if customers if we were breaking the latency requirements, or if there was poor synchronization or some other thing in the customer code that was actually the cause of the bad latencies. So and that was the progenitor to JRockit Flight Recorder, and then we did JRockit Flight Recorder. So the JRockit Flight Recorder, how many in here knows what JRockit JFR is? Still a lot of people that don't know. That's amazing. Like, okay. So this is a technology built into the Java runtime. It's a very high performance event recorder. Very low overhead. It records information continuously. There's APIs that you can use to put your own information in there if you would want to. And the idea with the flight recorder was that you would be able to use it like the flight recorder on an aircraft, right? So something bad happened. Let's go check the flight recorder, see if we can understand what was going on in the runtime at the time. And it has execution tracers and sampling profilers built in. So it's a pretty cool thing. If you haven't tried it, you should. It's open source also. So sampling profilers are basically the profilers where you would just, every once in a while, you would stop threads and you would ask, hey, what you doing? And walk the stack, and you would get the stack trace for what the thread was doing at the time. And depending on when you decide to stop that thread, that determines what the profiler is actually for. So if you're using CPU time to raise a signal and walk the stack, the samples will be associated with how much CPU time you've used. So how much CPU did you use and where? So then you have a CPU profiler. If you just decide to stop threads every 10 milliseconds or however often, then you get a wall clock profiler, because you will get a stack trace even if the thread wasn't doing anything on CPU. It was waiting on I/O or something. Then it's a wall clock profiler. And this is how it might look in mission control. If you look at what is almost a CPU profiler, we'll talk more about that later. But yeah, so here's a very simple example where you can see that we're doing a lot of equals checks in a linked list, and maybe switching to another data type, other collection type might be good, because we're doing a ton of contains checks here. So I know you can't see this. I'll share the slides later. Anyways, that's how that might look. We also have execution tracing. So execution tracing is a little bit different, because you typically have a function or method, typically in the runtime, instrumented so that you can get information from when that thing is called. So for example, whenever you're reading or writing to a socket or file, or whenever we're waiting to enter a monitor, it's usually also, an advantage is that you know exactly where you are for that instrumentation, right? So you can grab some additional context. So grab the file name to understand those file reads and writes, or grab the IP address, or the monitor address, or the thread ID of the thread actually holding on to the monitor that is, preventing you from entering that monitor. The problem with execution tracing is that it can be very hard to estimate the amount of data created. So you can get a lot of data, and for JFR, the typical mechanism to kind of deal with that is to have a threshold. So maybe you have a threshold for 10 milliseconds for Java monitor enter, right? Then you know that the outliers will be captured, but all the tiny ones that you probably don't care about won't be captured. And this is what this might look like from the execution tracer. In this case, we are kind of waiting. These, well, they should be salmon colored, but they don't look salmon here. Anyways, so you can see here that we're mostly waiting to enter the monitor, and then we have some other stuff going on here, which is the actual work. So we might want to look into that. So continue down memory lane. BA Systems, the people behind WebLogic Server, acquired Appeal Virtual Machines. They had acquired other technologies like Tuxedo and WebLogic Server, which is a popular Java application server. The important thing here for the story of continuous profiling is that they had something called execution context ID. So you could have a cluster of WebLogic servers, and that context would be tracked between these processes. So here's the kind of embryo for something that you would need to be able to do tracing well, right? And at the time, then JRockit became the default production runtime for WebLogic Server. So internally, of course, since they had purchased us and every other company that was part of their success, internally we called BA built entirely on acquisitions, which was very true. And also, since we were Swedes, and they had this thing, ad thing that they called Think Liquid, we saw that as an encouragement to drink liquid. Anyways, so in 2008, Oracle acquired BA Systems. This was super interesting because now there was this diagnostics framework within WebLogic Server that started to integrate with JFR in October 2008. And JRockit Mission Control 401 came out in 2010 with plugins available for WebLogic Server, where you could start breaking down the data by ECID. So you had profiling data that you could break down by context that was distributed. Context was king. This changed everything. In 2009, Oracle acquired Sun Microsystems. I was doing a lot of talks around this. I was jokingly referring to kind of the merger of JRockit technology and hotspot technology as HotRocket. At the time, JFR became not JRockit Flight Recorder, but now Java Flight Recorder. JMC became Java Mission Control, but these technologies were still only internally for Oracle JDK. It was still closed source. And at this time, some people at Oracle started to actually pull profiling data continuously. So they had scripts, they went through stuff, they were looking for long-lasting context, and they were seeing if they had data that could explain why things were taking a long time. So now we're almost at continuous profiling, right? In 2018, Oracle open sourced JFR and JMC, so it's a sensitive topic to call things Java. So it was renamed again to JDK Flight Recorder and JDK Mission Control in 2018. And this year, I had 6 sessions at Java 1 or Code 1. I recommend not doing 6 sessions at any conference ever. That's a really bad idea. But one of the sessions was about how you could use tracing and complement it with profiling data to do really interesting things and solve problems that would otherwise be very, very hard to solve. I built an open tracing extension, JFR plugin, for open tracing. So this was before OpenTelemetry. Had some microservices set up with problems in them and showed how you could solve the unknown unknown. You didn't know there could be a problem there. You had no idea. The tracer information doesn't give you the information you need. What do? Continuous profiling can help you. So I demoed using Jaeger and Mission Control. I was recording context. So that was really the trick. I was using JFR to provide my own events for spans and thread local activations of spans, something called scopes. For no good reason I have this, but it's funny, when Java turned 25 years, Twitter voted on best JDK technology, and surprisingly to me, Mission Control won that face-off on Twitter, so that was fun. Anyways, so we're now at continuous profiling. Continuously profiling. why would you spend resources to take stack traces all the time? What's the point? So I thought I'd spend a little bit of time talking about the last few years at Datadog and what we've seen using it internally. So for us, it's been a game changer. It helps optimize for both cost and performance. And you should care about performance, right? The customers will certainly care about the performance of your applications. So you can understand where the resources are being used. That is the normal profiling use case. You don't need many samples to be able to do this, right? You just need a statistical sample over whatever time period from your thing, and you will be able to determine where you're spending most of the time. Something that does require more samples is being able to understand long-lasting spans. What was going on here? I have this opaque box of something, and I can't understand what the code is doing here. And fixing latencies, for example, by understanding long spans is a very powerful technique. Always-on visibility helps solve problems. I'll give an example from a team within Datadog later in the talk. Again, we'll be talking about helping understanding the code in production, helping teams move faster. That's actually fun because I show a customer quote later where that's what they're saying. They're not saying that it's, they saved cost or they, made things go faster. They say their teams go faster. And anyways, profiling live production environments continuously with minimal overhead. I mean, the difference here from traditional profilers is that there is a hard requirement to not use resources. And I mean, we show everything. It's funny actually, because the first thing that happens happened when we introduced a new language from the continuous profiler was that our tracer becomes better very quickly, because the tracer starts showing up in customer profiles. And then it's like, what? What is Datadog doing here? It's stealing my resources. So that's been a pretty funny thing. There was a Twitter talk a couple of years ago where they were saying staging is not production, when they were talking about auto-tuning for performance. And that's, I think, a well-established fact at this point that product data from prod is very different to what you would get from staging. So it's not at all as useful. That said, continuous profiling can be used in staging, and customers do that because they want to capture problems early. So that's more for the diagnostics part of it. And it's low overhead enough that there are some services that are very edge case at Datadog. A few, just a very few. And that can't use tracing, but they can use continuous profiling because of the low overhead of continuous profilers. Cool. Of course, these are built for the modern development and deployment practices. Always on, meaning it's always there. You always have data. If something bad happens to you, there is always data that relates to your code where you can explain what was happening. And there are proven results. I'll get to that later. But we're saving millions upon millions of operational costs internally within Datadog just using this ourselves. And we do move faster internally, having profiling available. And we hear similar stories from the thousands upon thousands of customers we have that are actually doing continuous profiling in production. So I thought I'd share a few learnings. So at Datadog, caring about performance became an important part of what we do because it also affects the customer experience. You want something that responds quickly to what you're trying to do, right? It's part of the customer experience. A better customer experience means, earning more money, quite frankly. So the engineering culture started to shift a little bit. We didn't hide anything from the customers, including our own. Because, it's the observer effect, right? You look at something, you're going to change it, however little. But if you're changing it in a bad way, or something that actually affects the customer a lot, you will get a phone call. So, this is something that we decided early on to not hide anything. We introduced Slack channels, like performance wins and profiling. And the performance wins channel became popular, also because there was, anchoring from higher level executives like the CTO and the CEO were there, celebrating even small wins in those channels. And it started to become a thing where we just like, it was very common to get performance wins that translated into the hundreds of thousands, sometimes millions. We released a blog post not too long ago when one of the people on my team discovered in performance wins, started to just like, this is kind of a lot. Maybe we should write something, because it was 2 months where we kind of saved $17 million. And so we published a blog post around that. And recently we had a win that allowed us to use 1,900 cores less, so $3 million approximately in list price. So I have to confess something. I was going to talk about the velocity a little bit. I actually had a graph, but it was deemed too sensitive to show. So now I'm going to go show some anecdotal evidence from within Datadog. I have tons. If you want more, we can talk later. But I think these are funny. So I sometimes wonder how I lived without profiling. Yes, it's a very grim and dark life without continuous profiling, for sure. But the fun part here is, you have the data available. So the guy is saying that sometimes before, I would just move on. Maybe hope that I could catch a profile at some point, but here the profile is already available. So, dev experience is better. Here's another one that is also about the velocity. So the data science team saying that, we would never have made it to the GA at the Denver Summit if we didn't have profiling to focus our efforts for optimization and scaling. So again, speed. Here's another one, which is actually really funny. So this guy is saying that they had something really bad happening, an incident. They rolled back. Again, they are now running something different. But the continuous profiler has the data that they needed to, in seconds, understand what had actually happened and fix it. So rolling back, getting things to work, but you still have the data available. You can still go and look at what the code was doing. Yeah, this one is also funny. So differential analysis over flame graphs is a good thing. Okay, anyways, of course saving money is still a good thing. So I'm not saying that aspect of continuous profiling isn't worth anything. For example, here's a few ones that I screenshotted, but there's tons. You can see the blog about the 17 million if you want, but here is a few of them, few wins that we had. I'm not going to spend too much time on these, but that's good. Also, I kind of like when tools fulfill the Arthur C. Clarke's third law. Any sufficient technology is going to be indistinguishable from magic. So here's somebody at Datadog. I'm investing some slow query performance in Java, in a Java program. And I jumped from a span view in the trace to profiling using the button in the trace UI. And it's showing me the CPU for the time spent in that span. And it's right. How the hell did you pull that off? Are you tagging the profiles with span ID? Yes, we are. It's context. Context is everything here. Being able to slice and dice the data by having the context from the distributed operations in your system is everything. And it's not just Datadog. So I took a few customer quotes. The last one I didn't get approval for using yet. So it's software architect at Fortune 500 company. But it's really interesting to see here. Like, Datadog Continuous Profiler is extremely powerful and critical in our ability to quickly deliver new solutions. Nothing about saving money. It's about moving fast. And then the other one is just, helping to solve problems, which is also good, right? Helping to reduce the incident MTTRs, being faster in responses, being able to find problems faster that might otherwise be very hard to track down. That is all good. So I stole this. So a product manager, they have their uses, right? Had a really nice presentation on continuous profiling a while back, and I found this slide in his slide deck for continuous profiling, and it's a quote from Dumbledore of Hogwarts fame, happiness can be found even in the darkest of times if one only remembers to turn on the light. And I thought that was a really nice one, right? You have the light to shine on your code and how it's actually executing in production. So, what could be improved? So I'm going to mention two things, and one is actually underway, so it's kind of happening. In the method profiling tab that I showed you from JMC earlier when I was talking about sampling profilers, that was built up using the execution sample event. The execution sample event is not a true CPU profiler, it's an approximation. It takes 5 threads, then it checks to see if they are scheduled to run. If so, keeping the samples. If you had some trouble getting the sample, you would just skip that sample. If you couldn't walk the stack, there is no direct correlation with the amount of CPU time. So there hasn't been one, a true CPU profiler. Datadog has one, but we built it on our own. So you know, the community hasn't had a nice CPU profiler. But that is changing now. So there's a collaboration between Andrei Pangin, Johannes Bechberger, and Jaroslav Bashorik. Bashorik is Datadog, where we are donating a nice, good CPU profiler to JFR so that you can, in the future, do proper CPU profiling. Jaroslav this weekend, last weekend, had a talk at FOSDEM that is really good. I hope that will be available out at some point so you can see it. He goes through what we have been doing what work we have been doing for this. Okay. Oh well, what's in the context? After all, I suppose it would be frightfully dull and boring and completely wonderful. I hope I have convinced everybody in here that context is important. Now, the rest of the world isn't calling this context. I call it context because of the execution context ID from WLS, but the rest of the world is actually calling this profiling labels. So you would be better off calling this profiling labels. For Go, it's actually built in as a first-class citizen in the Go routine struct, which is very, very good, very nice. We don't have something similar for the JVM. There is a library that recently came out by Polar Signals that is providing custom profiling labels for Rust, Go, and C++. Of course, for Go, they don't need to do much because it's already there. But this is becoming a thing because it's, people are realizing how very useful this is. Of course, as we've been talking about, this allows for very simple and very cheap correlation between the events and something else. It can be span ID, trace ID, right? It can be something from tracing, but it doesn't have to be. You can use custom context to do very funny things. And if you want to know more about that, you can approach me afterwards and I can demo some crazy things we're doing internally at Datadog. But anyways, so we have multiple POCs built at Datadog for providing context. So POCs in OpenJDK code. We have one that is event-based for JFR. There is some advantages and there are some disadvantages to doing it like that. The advantages is that JFR events are structured. So whatever context you're providing can be, ints, longs, whatever. And you can have metadata to describe them, etc. And that's really nice. It's also really nice if you have something a context that lasts for a very long time and you have lots of events in there because, well, you have the event emitted in that thread over that time. And then, all those events will be post hoc. We'll fix it in post. All of that will be associated with that context. It doesn't work so well if you are in a situation where you get more context switches than actual events. So that's a negative for that approach. And it might not work so well if you want to be able to access that context from other tools. Let's say you have built a JVM TI-based profiler or a vmstruct-based profiler or a async at call trace-based profiler. So you kind of need to be a little bit careful there. For the label-based one, you would simply have a mechanism in the JDK that is very simple, where you can associate a thread or virtual thread with a context. And it doesn't need to propagate the context. That would be the responsibility of other tools, because you can't know who wants to do what or provide context how. So it's just a very, very simple mechanism. And that could then be surfaced through JFAR and other technologies. Of course, as I said, Datadog already have implementations in our own async at call trace and vmstruct-based profilers, but hopefully we could have that for everybody. So some final thoughts and recap. Continuous profiling is becoming the fourth pillar of observability. There is open standards being worked upon by OpenTelemetry, Open Tracing. It's already seeing very heavy use in critical production software all over the world. It differs from traditional profiling. There is a very strict demand for performance of the profilers, because it needs to be low overhead to be well, for multiple reasons. One is, of course, it's going to cost too much if it has high overhead, but also you will have the observer effect. You will affect what you're measuring, and the more you do that, the more you're going to be measuring your own profiler, which is not what you want to do. It's not only CPU profiling. There is a lot of other profilers that are really interesting. This is not the talk for talking about that, but there is CPU profilers, very specialized wall clock profilers. There is heap profilers. There is memory allocation profilers. There is a lot of different profilers that provide information that is critical to understand how you're utilizing limited resources on the system and things that might affect your latencies. There are some surprising benefits, like velocity of teams. So that part, it's funny how often that comes up, and not cost. So that's funny. Java has a bunch of really useful technologies already built in for being able to do things in this space. So we've been talking about JFR and JMC that half the room knows about. So there's an opportunity for half of you to actually start using some of these technologies to good use. They are open source, so just go there. But there is also other built-in things that probably people in the Java platform group would rather have me not mention, like using internal VM structs to be able to find things, to be using async at call trace, which is something that the Java team has been trying to get rid of for a very long time. JVMTI, JPLIS, so being able to do bytecode instrumentation for things that you might want to do execution tracing for example. Right. And we need a solution for context, I think, preferably one that can work for the future for profilers that also want to do profiling from outside of the process. There are prototypes available. Come, ping me, send me an email, whatever, if you want to, get links to those prototypes and try them out. This should be a core concept for observability in Java. And the next time you find yourself in trouble, in an escalation, I hope, may the fourth be with you. And finally, last slide, I am hiring for my team. I'm hiring a Java runtime engineer, remote, in the US or EMEA. I'm taking an opportunity here to reach out to all of you. Data science backend engineer in EMEA and a Java backend engineer in the US. So if this sounds like something for you, please come talk to me. And we have, oh, that went pretty fast. We now have time for questions. Oh, okay, be loud. Yeah? Okay. 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 I see. Yes, that's true. Okay, so the question was, there is somebody that is using Datadog here, and the profiling overhead was actually higher than advertised, but they are still using it. They have a replica set that they're using it against because it's finding a lot of problems for them. So there might be a few edge cases for the profiler. One is um, in certain conditions, using certain parts of the profiler, and you should come talk to me afterwards. You might want to turn off certain things. There is one thing that leads to, and shouldn't lead to, but does lead to native memory fragmentation. So that might be what you're seeing, and it's a thing that you can turn off. So if you don't need it, so come talk to me afterwards, and we'll fix that. And if there is any other Datadog customers here that is seeing more overhead, come talk to us, because you shouldn't. Then you might be in one of those edge cases or using an old agent. I've also seen, yeah. So we sometimes depend on APIs for other runtimes. We had a recent escalation where IBM J9 broke their implementation of a sync at call trace, and there's very little we can do when the JVM vendors break something. We can help try to fix it, but that's then we need to turn off things again for certain versions of the JVM. Cool. Any other questions around continuous profiling, methodologies, things happening? Sorry, come again. Yeah. Okay, yeah, so if 21 is better than 17. Well, we have been contributing to OpenJDK over the years to make things faster. There is a constant race of new things being added, and us trying to make sure that performance is what we need it to be. We, for example, donated an allocation profiler. I don't remember which version it came into. It might have been before 17, might be been 15. But for example, just to take an example, where the allocation profiler that is built into JFAR, there's two templates for JFAR. One is the continuous template, which is supposed to have less than 1% overhead, and then there is the profiling template, which is supposed to be 1 to 2 or whatever. I don't remember exactly what the promises are there. But there was an allocation profiler, and has been for a very long time, for the thread local area buffers, so you can find out where your memory pressure is being produced. That thing was only in the profiling template. They couldn't be used continuously. And the reason is, it is very hard to determine how many events you will get. We did some performance fixes to make it be faster, but that wasn't really the problem. The problem was that we could get billions of events, depending on how people have configured the sizes of their thread local area buffers. So we contributed an allocation profiler that has different performance properties, and is now in the continuous template, where it's guaranteed to be less than 1%. So we do care a lot about performance, and we're trying to find ways to make things go faster. I think that's also one of the reasons why we would be interested in having a standard implementation in OpenJDK for context, because it would be cheaper. It would be cheaper. So yeah. Hope that helps. We keep contributing to OpenJDK directly. I think we're actually one of the few vendors in the observability space that is constantly on the release blog for OpenJDK, where it's like these companies contributed, and Datadog. It's not our main job to contribute to OpenJDK, but we're trying to as much as we can make the world a better place for everybody. Okay, I have 5 minutes. Any other questions? Okay, if anybody wants demos around the things you can actually do with continuous profilers, I try to keep it vendor neutral by not having Datadog screenshots all over the place and try to use JMC to prove my points. But if somebody wants to see what the powerful continuous profiler can do, the continuous profiler is used almost everywhere at Datadog for every service, everywhere. We're heavy, well, dog fooders, of course, it's in the name. But we are using this internally a lot. So I could show you, you can't take any photos because I would be showing you internal Datadog stuff, I guess. But I can show you how this can be used to great effect, if you would like. Cool. Thanks, everyone. Get close early.